Alright guys, so continuing on in section 4.3, we saw that having the vertex form of the parabola is kind of really handy if we wanted to graph the thing. In standard form, it's kind of difficult because it doesn't really lend itself to like immediately go ahead and putting the vertex down and graphing it. So if we're ever given the equation in standard form, it's a nice thing to be able to change that to vertex form for the purpose of being able to graph it kind of quickly. So here's what we're going to do. We're going to have like a step-by-step of how do we do that. How do we go from standard form to vertex form? Let's see how this goes. So this is our equation. I made it up in my head. It's not in the book. F of x equals x squared minus 6x plus 1. So that's our standard form, ax squared plus bx plus c. And we're going to change that into vertex form. So before we start, I want you to come over here to the side with me, and let's. I just want to kind of mention something, kind of talk about a little idea before we go too far. Let's say I had the equation y equals 5x. There it is. If I go ahead, if I add 0 to that, if I do y equals 5x plus 0, I have not changed it at all. I kind of added something. I don't really need the 0, kind of extra stuff, but I haven't changed the equation from the original what it was. I haven't made it any different. I haven't added anything that I'm not allowed to add. I can actually change that a little bit more, and I can say y equals 5x. Let's do plus 7 minus 7. That would also still be like plus 7 minus 7. Those are just 0. And this is the same as this. So I can write this like this, and it still means the same thing as this first one did. We're going to do some of this along the way to over here to make this work. So I want to make sure that we're kind of okay with this. Okay? So plus 7 minus 7 does not change the original thing. Okay? So here we go. Let's jump in and see what we got to do. Okay, so the way we got to do this is similar to how we had to do the circle, where we had to complete the square. Okay, so we're going to complete the square with the x stuff. So let's rewrite this a little bit here. Let's go. Okay, so equals. Let's go ahead and group together the x stuff. So x squared minus 6x. I'm going to leave a space here inside this parenthesis that I'm making, and then have the plus 1 be on the outside over here. Hopefully we can see this okay. And then now what I want to look at now is, okay, I have this. Remember, to find the extra thing here in the completing the square, I had to take the b term, the middle one, so the minus 6, and then I had to divide by 2 and square it. And that's how that worked. So if I do negative 6 divided by 2 and squared it, that's the same thing as saying like negative 3 squared, and that's 9. So right here, I'm going to do plus 9. Okay. Now here's the thing. On this side, I've got in here I got plus 9. In the past with the circle, we had plus 9 here. We would add plus 9 to the other side. We don't really have another side right now, though. We're forced to deal with only the right side of this equation. We have f of x over here and everything else over here. So we have to just deal with the right side. I've done plus 9, but I want this to not be any different. So over here, I'm going to remember what happened over here. Plus 7 minus 7. I did plus 9 because that's what I needed, and then I'm going to do minus 9 over here. So plus 9, minus 9. I essentially have not changed this. I added the 9, but I took it right back away. So I didn't change the overall equation. So now what I can do is this one here, I can write this as the something squared. And so the something would be x right here. And then remember, it was whatever we got when we divided by 2, so right here, so the minus 3. So it'll be x minus 3 squared, and then whatever happens out here, I got a plus 1 minus 9, so that'd be minus 8. And there we go. There is our vertex form of the parabola. So, and then from this, we can very easily say, okay, well, where's the vertex? The vertex is at the point, we got a minus 3, so that becomes 3, and then we get a minus 8, and we get minus 8. So that's our vertex. We can find the axis of symmetry fairly easily. Remember, that's the line x equals, and it goes through the x coordinate of the vertex, so it'll be x equals 3. We also know, does it open up or does it open down? Looks like it opens up because it's positive, so we know it opens up. So then also we know that this vertex is a minimum value because this is opening up in both directions. And then also, we know, is it stretched or compressed? And it looks like it's not stretched or compressed. If there was a number out front here, remember if there was like a 2 out here, then it would be stretched to be skinnier. If there was like a half or a fraction out here, it would be compressed. So we'll just say not stretched. It's not stretched or compressed. There we go. So that's how we can change it from here to here. Go ahead and look in the book and try number 38. Try number 38 in the book and let me know how it comes out. Okay, I'm gonna say go ahead and just pause the video right now and then come back in a second and we'll look at the answer. Right, so pause the video and then we'll have the answer here in a little bit. Okay, so right now the video should be paused. Go. Okay, so hopefully we're coming back now to check our answer. So we got f of x equals x squared minus 2x minus 3. So let's go ahead and do what we got to do. So we're going to group the x's together. And so we got, this is going to be x squared minus 2x, leave the space, and then the minus 3 out here. To get the number in the middle, we got to do the minus 2 divided by 2 and square it. And so that's going to be negative 1 squared. That's 1. So right here we're going to do plus 1. We did plus 1 in here, so we got to do minus 1 out here. So that doesn't change the overall value of it. Now over here we've completed the square, so we can write it as something squared. And the something is going to be x and the minus 1 right there. And then whatever happens out here, it's going to be minus 3 minus 1, so that's a minus 4. So that's our vertex form of the parabola right there. And we can go ahead and see what's going on. We have the vertex. The vertex is going to be at the point 1 minus 4. The axis of symmetry is going to be x equals 1 because it goes through the 1 right there. It still opens up and it's not stretched. It's not stretched or compressed, and we're okay with that. So there we go. So hopefully that worked out pretty good for us. And this will work for any of those ones in there. Now let's go ahead and look at the next one here in the next video to look at one that's a little trickier.